Hi, today we'll be adding, subtracting, and multiplying matrices. Quickly, what is a matrix? A matrix is an array of numbers that are organized in a matrix, and the matrix is defined by these brackets right here. The numbers inside are called entries. So when it asks what are the entries of the matrix, basically it's asking for what are all the numbers inside of the matrix. So 6, 2, -1, -2, 0, and 5 are the entries of our matrix. The dimensions are organized by the number of rows by the number of columns. So we say R by C. In this case, the number of rows that we have are row 1 and row 2. So we have 2 rows by, and we have 3 columns going up and down. Column 1, column 2, and column 3. So it's 2 by 3 matrix are the dimensions of the matrix A. There are also different types of matrices that you'll see. So for example, the first one is called a row matrix. And the reason it's called a row matrix is because it's just made up of one row, which means that the second one is called a column matrix. Same reasoning as the first one. It has one column, hence why it's called a column matrix. The third matrix is a 3 by 3 matrix, and because it's the same number of rows as same number of columns, we call this a square matrix. And the last one is called a zero matrix because it's made up of all zeros. One of the things we are going to be doing is comparing. Comparing matrices is simple. As long as you see a matrix, for example, this one, that looks the same as the other one, then we say that they are the same matrix. They are equal matrices. Physically, when you look at them, they don't look the same, but mathematically, when you look at them, 2.5 is the same thing as 5 halves. -1 is the same thing as -1. -0.2 is the same thing as -1/5. And 3 is the same thing as 3. Therefore, these are equal matrices. If you look at the next example, example B, you'll see right away 1 is not the same thing as 0, and they are not located in the same spots. Therefore, these are not equal matrices. Going on to adding and subtracting matrices. Adding and subtracting matrices are simple if it's possible. So one way to know, it says perform the indicated operation if possible. To know if it's possible means that the matrix dimensions are equal. So in this case, there's 3 rows by 1 column, and the second one is also 3 rows by 1 column. Therefore, since they are the same dimensions, we can add these. And the way we add them is, and I'm going to erase those dimensions really quick, is take the first row, first column, first row, first column number, and add those 2 entries. So therefore, we get 1 in that same spot. Now, same thing with the 4 and -9. These are row 2, column 1 entries. So we are going to add them up, and we get -5. And lastly, we do row 3, column 1, add those up, and we get 11. Hence, when you add those 2 matrices, you get the following matrix, and that's our final answer. It's very simple. Same thing with subtraction. For example, number 2B, we take the row 1, column 1 entry and row 1, column 1 entry of this second matrix, and we subtract the 2. So our answers are going to be 1 when you subtract those. Same thing with 3 minus 0 is 3. 9 minus -3. Be careful there, because a 9 minus a -3 is technically the same thing as 9 plus 3. Therefore, that's 12. And then lastly, we get -5 minus 5. is negative 10. Looking at the last example we have, the dimensions of this is 1 by 2 and 2 by 2. Therefore, the dimensions do not match up, and this is not possible to add. Let's go on to example 3, where we multiply a matrix by a scalar. A scalar just means a number on the outside of the matrix. For example, 6 in this case is our scalar. So all you do is pretend like you are distributing. So you distribute the number 6 to every entry inside of the matrix. And it looks really messy, so I'm going to erase that. And what we end up getting is 6 times 2 is 12. 6 times negative 3 is negative 18. 6 times 8 is 48. And lastly, 24. And that's our final answer for multiplying by a scalar. We can also solve a matrix equation. And here it says solve the matrix equation for x and y, and you'll notice that there's x's and y's in certain spots. I'm going to make it a little bit bigger. There we go, so we can see it. What you have to do is follow the order of operations carefully. So if you notice that the scalar 4 is on the outside of the parentheses, so first we're going to work with the inside of the parentheses by adding these matrices. And if the numbers, you'll see in just a minute, if the numbers add up, we'll add them up. If not, we'll leave it as an expression. So 8 plus 4 is 12. 0 plus negative 2x is just negative 2x. It's okay to have x's in your answer. Negative 1 plus 1 is 0. And 2y plus 6 is 2y plus 6. Since they're not like terms, we're not going to add them. And I'm going to close that parentheses, and it equals the matrix that we see on the right side. Now, the last thing we have to do is make sure we distribute the scalar number to the matrix. So we get 4 times 12 is 48. 4 times 0 is 0. We have 4 times negative 2x is negative 8x. And when you're multiplying or distributing that 4 to this expression 2y plus 6, make sure you do it to every part of it. So it's going to be 4 times 2y, which is 8y. But you're also going to do 4 times 6, which is plus 24, equals the expression that we see on the right side again. So here's that matrix. And then what you'll notice is a couple things. 48 is equal to 48. So these are equal matrices. We got 0 and 0 in the right spots. And what you'll notice is negative 8x is supposed to equal negative 48. So we're going to go ahead and make that our expression. And we're going to solve for x. In this case, x equals 6. Lastly, you can take 8y plus 24 and set it equal to 8. So we have 8y equals, plus 24 equals 8. And we're going to go ahead and subtract 24 to the other side. And we get negative 16. Divided by 8, we get y equals negative 2. So here are our solutions for x and y. X equals 6 and y equals negative 2. Our second goal is to multiply matrices together. And we're no longer talking about scalar matrices. What we're talking about is a matrix multiplied by a matrix. So the rules change a little bit. So for example, we have a matrix A and a matrix B, and if we're trying to multiply these two matrices, then the dimensions are important. So let's say that A is m by n. So those are the dimensions of matrix A. And let's say matrix B is n by p. P, these two matrices can be multiplied because the column of the first matrix and the row of the second matrix are equal in value. So therefore we can multiply them. And when we do, then the dimensions we're going to get are going to be what I didn't circle. So AB is going to be our product. And we are going to get dimensions of M by P. And you'll see that those are the ones that kind of were left on the outside. So first thing we want to do before, and let's write that down here actually. But first thing we want to do before we get too ahead of ourselves is make sure we can identify if we can multiply the matrices so we're not wasting time. So it says, state whether AB is defined. If so, give the dimensions. So looking at the dimensions, we're trying to see if AB can be multiplied together. Matrix has the dimensions of 2 by 4, and B has 4 by 3. And looking at it closely, we can see that the column of matrix A and the row of matrix B are equal in value. Therefore, we can multiply them. And if we were to multiply these, then the dimensions of our product would be a 2 by 3. So that's ultimately what we're looking at. Now, looking at the second one, we're going to try to do the same thing. The dimensions of A is 1 by 4, and same thing with B. And a lot of people assume, oh, it's like addition and subtraction, we can do it. But unfortunately, like I said, the columns and the row of the second matrix do not match up. And because they're not equal, therefore we cannot, this is not possible to multiply. So we kind of have to stop there because we can't do it. Scrolling down a little bit, we now have the product of two matrices. This we will be doing on the calculator, so please go ahead and take out your TIs. And what you'll notice is once you have your TI out, there is a matrix button right underneath math. So to get to that, you are going to press second x to the -1. And we're going to go ahead and scroll to the right twice to the edit section. And we're going to edit matrix A so that it looks just like the matrix A that's given to us. Sorry, my calculator just went to the back, but that's what I want you to make it look like. So the dimensions on that is a 3 by 2. So we're going to go ahead and just type in 3, enter, 2, enter. After every number, just go ahead and press enter so it goes to the next spot. And then make sure that the matrices that you see on the calculator is just the same as the matrices that we have on our papers here. And then once you have that, we're going to go ahead and quit out of here. And we're going to go back to matrices again. And we're going to this time edit as well. But this time, instead of editing, sorry, I did it one more time. Instead of editing matrix A, we're going to go ahead and edit matrix B. So I'm going to go scroll down one to matrix B, enter it. This is a form of matrix I used to have. So it's not, this matrix we're working for is not a 3 by 2. It's definitely a 2 by 2. So we're going to go ahead and do 2, enter, 2, enter, and then go ahead and put the entries in. Double check, and it looks like it's good. We're going to go ahead and quit out of here. What we want to do on our calculator, we're going to go back into matrices again, is say that we are going to multiply matrix A. So we're going to press enter, get it into the home page, times, and we're going to go back to matrices again and grab matrix B and press enter, and that's the answer that we have. So once you write it on your paper, then you are done with multiplying two matrices. All right, guys, this is it for today. Make sure you review your notes. If you need to watch the video again, go ahead and do so. If not, we will practice in class tomorrow. See you.